Back. This is the second lesson in Module 2, and this is the final video for that lesson. So let's get started here. In the earlier videos, we looked at we reviewed how to multiply two binomials together, and we saw the result was this quadratic expression here. Okay. Then we did some practice with multiplying binomials, but we only multiplied binomials that had like a 1x and a 1x right here. And we multiplied it out. We ended up with all this work right here that we saw, these answers. And we saw that, there was a quicker way to multiply these out using just how the results of the numbers worked and stuff like that. So for example, the x and the x resulted in the x squared there. The 1 and the -7, if you add them, you get the middle term, -6. And then 1 times -7, if you multiply those terms, you get the last term, the -7 there. And then using those ideas, that allowed us to develop a strategy for factoring, going backwards, these quadratic expressions, right? So that right here, 7, 8, and 9, these were the answers in the earlier problems for 2 through 6, right? These guys right here. But now we're going to take those answers and work backwards to get the original factors that we multiply together. Okay, so we were basically breaking these up into just their two factors. Not every quadratic factors, so you might get to a place that's impossible. Okay, so keep that in mind as well. And again, the strategy was you looked for two numbers that multiply to make your last term and add to make your middle term. And this strategy only works completely for when you have a lead coefficient of 1. And all these problems have a lead coefficient of 1. All right, so example 3. If the leading coefficient for a quadratic expression is not 1, the first step in factoring should be to see if all the terms in the expanded form have a common factor. So in other words, look for a GCF. Then after factoring out the GCF, it may be possible to factor again. So when it comes to factoring, right, we use that word factoring to do different things. Greatest common factor, this quadratic factoring we're doing. So I would always encourage you to look for a GCF first, and then continue factoring using your other strategies. But a GCF is always a good idea to start with because it helps you to reduce things to more simple numbers. So here's an example. Let's say we want to factor this, right? It's not quadratic, so we can't use that rule that we used earlier, but we do see there's a GCF, right? You can take out a GCF of 2x, which leaves behind this x squared minus 25. If you remember from a previous lesson, right, that we have a difference of squares here. And so this factors to be x minus 5 and x plus 5. If you're afraid that you're not going to be able to remember that difference of squares thing, you can also think of this as x squared plus 0x minus 25, which then puts it in the form very much like the earlier problems that we did in the previous video. And we can use that rule where we look for two numbers that multiply to make this -25 and add to make 0. What two numbers multiply to make -25 but add to make 0? Well, that's going to be -5 and +5. And hey, there are your answers. All right, so let's try this for another problem right here. So here's our GCF. No, sorry, not our GCF. This is our polynomial we want to factor. So is there a GCF? Is there something we can divide all three of these numbers by? So some of you might look at this and say, these all divide by 2. And yes, you can divide all these by 2. So if we divided 2 out, we'll end up with 2 and then -8t squared 16t plus 24. And now you might look at this and say, whoa, wait a minute, we can take out more. Those numbers are still divisible. We can take out, let's see, we can take out another 2. So we'll now have a 4 out front. Okay, but we can still divide by 2. In fact, we can divide by 2 more times. So let's just go ahead and divide everything in here by 4. Okay, because it was all divided by 4. So it's already a 4 out front. If we divide another 4 out, we'll have a 16. You multiply when you pull stuff out there. We'll have then -t squared plus 2t plus 3. Okay, and so there's our GCF. 16. So some of you might have seen that right off the bat, you could have divided all three of these numbers by a 16 in the first place. One other thing I'll really encourage you to do, we have a -1 in front of our t squared. All the factoring we've done of the quadratics up to this point had positive 1s in front of our squared terms. So let's go ahead and factor out this -1 here, so that way we don't have to worry about dealing with negatives. Okay, so last step we'll say then we have -16 positive t squared -2t minus 3. Okay, and so we're going to then try and factor this. So we still have the negative 16 t squared minus 2t minus 3. We're going to look at this quadratic here. Remember our strategy, because we have a positive 1 for our lead coefficient. We can use that strategy. We want to multiply to make what? We want to add to make what? So stop and think about that. What number in here, what number in this quadratic do we want to multiply to be? What number in this quadratic do we want to add to be? So we want to multiply to negative 3. We want to add to negative 2. So again, think of two numbers that multiply to make negative 3 and whoops, and add to make negative 2. Okay, what are those two numbers? It's negative 3 and positive 1. Or you might have written positive 1 and negative 3 like that, and that's fine. So however, whatever order you want. And there it is, completely factored. Okay, so here's a lesson summary. Multiplying binomials, which is what we did at the very, very start in the first video, is an application of the distributive property. Each term in the first binomial is distributed over the terms of the second binomial, right? Or you can use the table method in that case too. All right, when factoring trinomial expressions, all right, which is what we just did, it is useful to look for a GCF as your first step. Okay, and then don't forget about the special cases we talked about, squaring a binomial and the product of the sum and difference of two expressions. Okay, so, but again, you'll be able to use these strategies that we just talked about here to help you with some of that factoring too. All right, thanks guys, and we'll see you in the next lesson.